Welcome, gem enthusiasts, to a journey that takes us deep beneath the Earth's surface and into the fascinating world of gemstones. These captivating treasures, prized for their beauty, durability, and rarity, have held human fascination for centuries. But have you ever wondered how these geological marvels are formed and brought to light? Join us as we unearth the secrets behind gemstone creation, the diverse mining techniques employed to extract them, the crucial role of environmental responsibility, and the incredible journey these gems undertake to become the objects of our desire. Gemstones are not merely pretty rocks, they are geological marvels that offer a window into Earth's deep history. Their formation is intricately linked to various geological processes occurring over vast timescales. These processes, often driven by the Earth's dynamic tectonic activity, create the unique conditions necessary for specific minerals to crystallize into the gemstones we admire. Metamorphic magic. Many premier gemstone deposits are born from conditions of extreme stress, pressure, and temperature deep within the Earth's crust. This process, known as metamorphism, occurs when existing rocks are transformed in the solid state during tectonic events. Pre-existing minerals become unstable and are replaced by new ones, sometimes resulting in the formation of stunning gemstones. Sapphires and rubies, both varieties of the mineral corundum, are often formed under these metamorphic conditions. The intense blue color of sapphire is often due to trace amounts of iron and titanium. Similarly, the formation of spinel, which comes in various colors including prized cobalt blue, can occur in dolomitic marble that has undergone high pressure and high temperature metamorphism. Interestingly, these metamorphic gemstones often bear signs of their formation history in their inclusions, which can mirror their geological conditions. Igneous origins and pegmatite powerhouses. Another significant environment for gemstone formation is associated with magmatic processes. As molten rock, or magma, cools and solidifies, it can create various types of rocks, including those that host gemstones. Pegmatites are a particularly interesting type of igneous rock known for yielding a remarkable abundance and variety of gem minerals. These are unusual magma bodies, where water and elements that don't readily fit into common minerals become concentrated in the final stages of crystallization. When this water-rich magma, also rich in silica and unusual elements like beryllium and boron, is expelled, it solidifies to form pegmatites, often containing large crystals of aquamarine, tourmaline, and topaz, among others. Hydrothermal adventures. Gemstones can also crystallize from hydrothermal solutions. This process is similar to gem formation for near-surface water. Rainwater or water derived from cooling magma bodies can dissolve minerals. When these solutions encounter open spaces, like cracks, and the physical conditions change, for example, cooling, minerals precipitate out, forming veins of crystals. Beryl, the mineral that includes the vibrant green emerald, often forms through such hydrothermal processes, requiring unusual elements like beryllium sourced from cooling magma. Near-surface secrets. Closer to the Earth's surface, gems can form through the interaction of water with minerals. As water dissolves minerals and then evaporates or cools, dissolved elements can precipitate out, forming crystals. This process is akin to the formation of salt crystals from evaporating seawater. Deep mantle diamonds and kimberlite rockets. The most famous gemstone of all, the diamond, has a unique origin deep within the Earth's mantle. These geological marvels are often brought to the surface through volcanic eruptions of a specific type of igneous rock called kimberlite. Over millions of years, diamonds are sometimes removed from their primary kimberlite source by natural erosion and deposited in new environments. Kimberlites exhibit unique geochemical characteristics, reflecting their deep mantle origin. Exploration for diamonds often involves searching for kimberlitic indicator minerals. Alluvial treasures. Nature's redistribution. Once gemstones are formed in their primary geological settings, natural forces like erosion by flowing water can liberate them and transport them to new locations. Sediments deposited by flowing water are termed alluvial. Alluvial diamonds, along with other gemstones like garnets and zircons, are often found in riverbeds, coastlines, and ocean floors. Alluvial mining involves sifting through these sediments to recover the precious gems. The quest for gemstones has a long and fascinating history. Ancient civilizations, like the Egyptians, undertook extensive mining expeditions to acquire desired gems. These early efforts often involved heavy manual labor, with teams trekking into remote areas for extended periods. Today, gemstone mining employs a variety of methods, which have evolved with technological advancements. The choice of method largely depends on the type and location of the gemstone deposit. Underground mining. When gemstone deposits are located deep within the rock, underground mining techniques are employed. This involves digging tunnels, shafts, and chambers to access the gem-bearing ore, which is then extracted using tools like pickaxes and sometimes more advanced machinery. Rubies and emeralds are often extracted through underground mining. Open-pit mining. For gemstone deposits closer to the Earth's surface, open-pit mining is a common method. This involves removing layers of soil and rock to create large, wide pits, eventually exposing the gem-bearing material. Diamonds and sapphires are sometimes mined using open-pit techniques. Once exhausted, some open-pit mines are reclaimed and can be transformed into wetlands, community spaces, or parks. Alluvial mining. As mentioned earlier, alluvial mining focuses on recovering gemstones from sediments deposited by water. This method can range from simple artisanal techniques using shovels and sieves to sift through sediment to more intensive hydraulic mining methods. Alluvial deposits are a significant source of gemstones like alluvial diamonds, garnets, and zircons. It's important to note that gemstone mining, like any extractive industry, carries ethical implications and can have significant environmental and social impacts if not done responsibly. The connection between gemstones and the fragile ecosystems from which they are extracted is complex and dynamic. There is a growing imperative for the gemstone industry to examine and address the social and environmental responsibilities associated with the production, trade, and consumption of colored gemstones. Historically, there has been a lack of proactive progress in mitigating factors that degrade vulnerable regional environments. Identifying environmental challenges. Gemstone mining can lead to various environmental challenges, including habitat fragmentation and destruction, which can threaten sensitive and sometimes endangered wildlife. Deforestation, soil erosion, and the alteration of natural drainage patterns are also common consequences. Additionally, hunting linked to artisanal mining can impact local wildlife populations. The creation of unfilled mining pits can riddle landscapes, posing safety hazards and leading to stagnant water, which can increase the incidence of diseases like malaria. Mitigation and solutions. Many of the ecological problems associated with mining can be overcome by designing and implementing effective mitigation strategies. Reclamation and remediation of unfilled pits are crucial steps in restoring mine areas. Responsible mining practices, such as reducing water use, minimizing land disturbance, and ensuring safe working conditions for miners, are becoming increasingly important for a sustainable and equitable industry. Conservation gemology is an approach that seeks to address the pressures of mining on sensitive wildlife habitats. Formalization and governance. For regulations to be realistically implementable, they must be adapted to the size and nature of mining activities, recognizing that artisanal miners often lack the knowledge and resources of large-scale operations. Governments, in collaboration with the industry, need to be proactive in managing these challenges. Fostering environmental responsibility at grassroots level through innovative local governance and efforts to formalize operations is key to preventing miners from entering protected spaces. Greater transparency at the production and trading levels is also essential. The environmental consequences of gemstone extraction and consumption are the responsibility of all industry stakeholders, from miners to consumers. Protecting the environment is not only an ethical imperative but also vital for the long-term sustainability of livelihoods in gem-producing regions. Finding gemstone deposits can be a challenging endeavor. Historically, exploration has often been a hit-and-miss process, particularly at the artisanal level, where miners dig with basic tools hoping to get lucky. Deposits can be small and widely dispersed. However, modern science and technology are offering new approaches to gemstone exploration. Indicator minerals. In the search for primary diamond deposits, geologists often look for indicator minerals associated with kimberlite pipes. Sampling stream sediments and soils for these specific minerals can help pinpoint potential diamond-bearing areas. Geophysical methods. Geophysics plays an increasingly important role in gemstone exploration. Various techniques can be used to image subsurface geological features that might host gemstones. Ground-penetrating radar (GPR) is effective for mapping shallow sedimentary alluvial structures, potentially identifying gem-bearing gravels within a few meters of the surface. However, its penetration depth is limited, and it doesn't work well in areas with conductive clays. Geochemical surveys involving systematic soil sampling and multi-element analysis can help identify areas with elevated concentrations of elements associated with certain gemstones, such as emeralds. Magnetic surveys can detect differences in magnetic properties between kimberlites and surrounding rocks, aiding in the location of potential diamond pipes. Seismic reflection profiling, while traditionally used for deeper geological investigations, has the potential to be refined for identifying relatively small, shallow features relevant to gem exploration. This technique involves generating vibrational waves and analyzing their reflections from subsurface rock layers. Three-dimensional 3D modeling integrates various datasets like drill hole data and geophysical surveys to create detailed subsurface representations of kimberlite bodies, helping to identify potential diamond-bearing zones. Airborne electrical prospecting technologies, using helicopters and UAVs, are also being explored for their potential in searching for kimberlite pipes. The application of these geophysical methods can optimize the chances of successful gem exploration and provide valuable knowledge about existing deposits. However, factors like cost and the need for specialized expertise are important considerations. There is also a social and economic impact to consider, as the introduction of high-tech exploration methods can affect local artisanal miners who have relied on low-tech methods for generations. Once a rough gemstone is extracted from the earth, its journey is far from over. It undergoes a meticulous transformation to reveal its inner beauty. This process often begins with cutting and polishing, a skilled craft known as lapidary. This requires both artistic vision and scientific precision to shape and facet the gemstone, maximizing its brilliance and color. The final gemstone then has diverse applications, adorning jewelry, playing crucial roles in technology, for example, sapphire in watch crystals and electronic components, and even contributing to scientific research. The marketing and pricing of gemstones are also integral to their transition from the mine to the market. Often perceived as flaws, gemstone inclusions are actually fascinating materials or voids within a gemstone that deviate from its primary composition. These can include other minerals, fluids, gases, or even entirely different gemstones. Far from being mere imperfections, inclusions imbue gemstones with unparalleled depth of character and unique individuality. They offer a captivating story that traces back to the gemstone's geological origins and can even help determine its provenance. For example, elongated crystals of rutile within sapphires, often called silk, can create the mesmerizing star effect seen in star sapphires. The very forces that shape our planet's continents through plate tectonics also play a significant role in the formation of certain gemstones. The movement and interaction of tectonic plates create the unique pressure and temperature conditions necessary for specific gems to form. Jadeite, a subduction zone gem. Jadeite, a highly revered form of jade, is characteristically produced in subduction zones, where one tectonic plate slides beneath another. It is often found in association with other high-pressure, low-temperature metamorphic rocks that are diagnostic of fossil subduction zones. Ruby, a collision zone creation. In contrast, the gem variety of corundum, ruby, is characteristically formed in continental collision zones, where two continental plates collide. These plate tectonic gemstones provide valuable insights into the fundamental geological processes that created them. The journey of a gemstone, from its formation deep within the earth to its dazzling presentation, is a testament to the power of geological processes and human ingenuity. Understanding this journey highlights not only the incredible beauty of these natural treasures, but also the importance of responsible and sustainable practices in their extraction. So, the next time you admire a gemstone, remember the remarkable story it carries within its sparkle, a story etched in the Earth's history and brought to light through a fascinating interplay of science and human endeavor. Thank you for joining us on this gem-filled exploration.
Welcome to the world of geology and earth sciences with Ricardo Voles, a seasoned professional geologist, bringing you over 1,000 videos of unparalleled expertise. Whether you're a budding graduate student, an early career specialist, or a seasoned professional, this channel is your gateway to a wealth of knowledge. Explore a vast array of Earth-related subjects, including geology, geochemistry, structural geology, and the application of artificial intelligence and machine learning in geosciences. Stay ahead of the curve with our latest content, covering everything from unraveling the Earth's secrets to exploring global geological phenomena. Subscribe now, hit that like button, and share this invaluable resource with your colleagues and friends. Join our growing community of over 1,800 Earth science enthusiasts and professionals today. Unlock the secrets of the Earth with Ricardo Voles, your top resource for all things geology. The future of geosciences is here. Be part of it.
Incredible insights.
Incredible insights.
Incredible insights.
Incredible insights.
Welcome. Today we're exploring an incredible book on geology by Voles Geoconsultant, designed for anyone looking to deepen their understanding of our planet.
This book provided fascinating details I never knew.
I love how easily it explains complex concepts.
It's a must-have for any geology enthusiast.
Absolutely. It's both entertaining and informative.
Unlock the mysteries of our planet with this book. Grab your copy today and start your geological journey.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.